Welcome to Lesson 3-2A. Yes, Lesson 3-2A. We've broken Lesson 3-2 into two parts because it covered a lot of stuff. So we wanted to break it into 2 days. So anyway, this is going to be the greatest common factor. And I'm sure you're asking yourself, what is this greatest common factor he speaks of? Well, let me explain. Well, look at this. We have two adjectives and a noun, or is the first one an adverb? I forget. I guess I don't need to know that in the math world. Adverbs describe verbs, and I think adjectives. But is it describing common, or is it describing fact? I don't know. Anyway, we have factor is the main noun here. That's the thing we're talking about. A factor is a number that can divide evenly into a larger number, and all numbers can be broken down into factors. So the factors of 24, there's quite a few of them, are 1, 2, 3, 4, 6, 8, 12, and 24. Now moving on to our first adjective, common. Common is describing factor. It's common factors are involving two or more numbers. And we want to know of all the factors they have, which ones do they share in common? So let's look at, I don't know, how about 16? So here are all the factors of 16. 1, 2, 4, 8, and 16 all divide evenly into 16. And if I were looking for the common factors, they both have a 1, they both have a 2, they both have a 4, they both have an 8, and that's it. Those are all the common factors of 24 and 16. And now we're looking at the word greatest means the most, the biggest. So what is the biggest of the common factors they have? I can all hear you saying, me, ooh, I know. Yes, it's 8. You're all correct. It is 8. So the greatest common factor of 24 and 16 is 8. Before moving on, we need to define a couple more ideas, a couple more terms, and you may have heard of these things before. We have prime numbers and composite numbers. So prime numbers have exactly two factors, 1 and itself. For example, 5. 5 can only be divided by 1 and itself 5. So 5 is prime. So what is a composite number? Composite numbers have more than two factors. They're made up of prime numbers. For example, 15 is composite. You can divide it by 1, 3, 5, and 15. It has more than two factors, and that makes it composite. All right, factor trees. This sounds nice. Factor trees. Oh, everyone likes trees. So factor trees are a way to break composite numbers down into their prime numbers. So let's look at an example. If I have the number 20, I need to think to myself, what two numbers multiply together to give me 20? And I know what you're thinking. You're thinking there's lots of possibilities. I could do 1 and 20, but if I did that, I'd still have 20. It doesn't do me any good. I could do 2 times 10. I could do 4 times 5. All of these are options, and guess what? It doesn't matter which route you travel, you'll get to the same place. I'm going to do 4 and 5. Every time I get to a prime number, I'm going to circle it, and that is where I'm going to stop. Because I could say, oh yeah, 1 times 5 equals 5, but I still have a 5. I haven't done anything. So that's done, and this is 2 times 2, and those are prime, so I'm going to stop. And so 20 can be written as a product of its prime factors. 2 times 2 times 5. 2 times 2 times 5 are the prime factors of 20, and so that's called the prime factorization. Now, one thing to notice is that if I were to list all the factors of 20, I could make all of these factors with the prime factors that I have. So 1 is 1, so there's a 1 here. So that's that one. 2, well, there's your 2. 2 times 2 is 4. I have a 5. There's a 5. 10 is 2 times 5. There's that. And 20 is just all of them put together, multiplied, is 20. So I can make all the factors of 20 out of its prime factors. And that's going to be useful later on. All right, let's find the prime factorization of 56. So we're going to make a factor tree. And that's 7 times 8. That's prime. That's 4 times 2, and that's prime. And that's 2 times 2. And now I'm done. I have all prime numbers. And so we could say 56 equals 2 times 2 times 2 times 7. Now, if you want to get real fancy, there's another way to write that. I could say that's equal to 2 to the third power times 7. Ha ha ha. Yes. I rewrote 2 times 2 times 2 as 2 to the third power to save a little writing. So there you go. Either is acceptable. All right, now it's your turn. Find the prime factorization of 60 any way you want to do it. All right, now we're going to find the greatest common factor of two or more numbers, and we're going to do that two different methods. First, we're going to do it the old-fashioned way where we list all the factors and look for the biggest one they have in common. And then the other way we're going to do it is factor trees, which is way more powerful, but you got to know your stuff. Okay, by listing all the factors out, which is the way you know and love, you would find the greatest factor that they have in common is 6. They do share other common factors. They share a 1, a 2, and a 3, but the greatest of them is 6. Now, the problem with this method is, even though it's pretty straightforward, is did you know that 42 could be divided by 14 or 21? Maybe you did, maybe you didn't, but there's definitely room for making mistakes. All right, I'm going to show you the factor tree method now. The factor tree method involves doing factor trees, prime factorizations for the two numbers. Okay, so I get 2 and 2. So this is 2 times 3. And 42, that's just 6 times 7. That's prime, and that's 2 times 3. So this didn't take too long. Didn't take too much mental energy. And as I said before, the 2 and 2 and 3 are all the fixins to make a 12. And the 2 and the 3 and the 7, well, those are the ingredients to make yourself up a good cup of 42. And so I can make all the factors of 12 and all the factors of 42 from their respective prime factorization numbers, factors thingies. All right, so I'm going to look for the factors that they share. They both have a 2. They both can be divided by 2. And they both can be divided by 3. Now 12 has another 2, but 42 doesn't. And 42 has a 7, but 12 doesn't. So the only common factors they share is 2 times 3. And so my greatest common factor is 2 times 3, which is 6. And I got that without having to, I don't know, think so hard. I got another method, though, for that to be useful. All right, I'm going to use factor trees to do this because I love the factor trees. So 24 is just 4 times 2, 3, 2, 6 times 3, 5, 3, 5, 8, 2, 5, 2, 9, 2. Looks to me like they both have a 2. They both have a second 2. And that's about it. Now all three numbers have some other factors. 24 and 36 each have a 3, but 8 doesn't. 8 has another 2, but 36 doesn't. And so on and so forth. Those are the ones they share. So the greatest common factor is 2 times 2, which is 4. You could list out all the factors of those three numbers, and you'd find that is your answer. I'd like you to find the greatest common factor of 50 and 15. Let me know what you find. All right, let's put this to use. Keisha's putting together bags of supplies. She wants an equal number of craft sticks and glue bottles in each bag. There are no supplies left over. What's the greatest number of bags that she can make? So she wants to, she's not going to have the same number of glue sticks and craft sticks in one bag, but she's going to have an equal number of bags, and they're both going to have glue and craft sticks. So I need basically to be able to divide 12 by a number and 42 by the same number, and I want it to be the biggest number possible. So that's the greatest common factor. Let's do this. So here's the prime factorization of both numbers. And let's look for the numbers that they share. They both have a 2. This has a 2, 12 has a 2, but 42 does not have another 2, but 12 has a 3, and so does 42. And so that's it. This 42 has a 7, but 12 does not. And so the greatest common factor is 2 times 3, or 6. So we can make 6 bags. That means each bag would have 2 bottles of glue and 7 craft sticks. Okay, knowing that we have 6 bags, Keisha wants to put her 24 beads that she has equally distributed amongst those 6 bags. So, can she do it? Can she make 6 bags and have no supplies left over? Show us why. Alrighty, we have some straight up practice here. And so what is the prime factorization of 32? So we're going to take our 32, we're going to factor that baby into its prime numbers. The next one, we're going to find the greatest common factor of 100 and also the number 48. You can use factor trees. That's going to be super powerful, but you got to know your stuff. Or you could list out the factors of both numbers and find the greatest one. Hope you list them all. Didn't forget any. But anyway, go ahead and solve those, and we will talk about them in class.